What occurred before the huge explosion? That is the most troublesome inquiry today. With the Hubble telescope, we can see in excess of 100 billion systems, each containing maybe many billions of stars. But how did this happen? Why is there something, and for what reason isn't there nothing? This question is a major issue for some religions. It appears that someone had to create a universe as large as it is. How can all of this come from nothing? In 1926, Edwin Hubble figured out that our universe isn't the only one in existence. After an additional 3 years, he discovered that different galaxies were moving away from us. Following this astonishing revelation, it seemed that we were at the focal point of the universe. However, Hubble's observations suggested that the universe is expanding. Regardless of which galaxy you observe, it appears that everything around us is expanding. Everything that surrounds us has a past: humanity, plants, animals, the environment, the seas, the land, and the planet Earth itself. The Sun is slightly older than the Earth, and the galaxy is much older than the Sun. So, both Earth and the Sun have their own histories, as does the universe, which appeared around 10 to 12 billion years ago. When people first heard about the Big Bang, they wondered, what happened here? At first, this may seem like a simple question that anyone could ask. In reality, however, this is perhaps the most difficult question, and so far, no one has been able to answer it definitively. This situation didn't sit well with scientists, who are used to finding answers to various questions, even very challenging ones. Researchers arrived at not just one but a series of answers, many of which were incredibly strange and incomprehensible to most people. The first response was that there was nothing before the Big Bang. It turns out that the universe emerged from nothing, meaning everything came from nothing. This is difficult to imagine. How and why could this happen? Everyone would agree that not only can you not create a universe from nothing, but you also couldn't make even a stool from nothing. It is possible, however, that there were types of substances in the mysterious nothing that are unfamiliar to us, and that this nothing was not completely empty. There were some processes that could lead to small explosions and, eventually, to the Big Bang. To confirm this theory, scientists are attempting to replicate nothing. They've built special chambers from which particles of matter were removed, lowered the temperature, and nearly reached the cold of outer space. It turns out that the resulting nothing actually represents something and can be explored in various ways. Opponents of this theory answer the question of what occurred before the Big Bang in completely different ways. However, the main idea is that the Big Bang is a unique event in the history of the universe, but the universe existed before that. So far, little can be said about what this predecessor of our universe was like, but it is assumed that something happened in history that led to the Big Bang, which created our universe. Many agree with this, although there are other opinions as well. Perhaps there was a universe before the Big Bang, similar to our own, or maybe not similar at all. Some suggest that before our universe, there were likely 2 different universes, and their collision led to the Big Bang. Finally, it is assumed, and some agree, that a truly complex event occurred in the first moment of our universe's history. The infant universe expanded rapidly to massive sizes, creating bubbles from which different universes grew independently. This is how the so-called Great Universe, also known as the multiverse, might have come into existence. If this is true, just as our galaxy is one of the billions of galaxies known to us today, our universe could be one of many other universes that are completely unknown to us. Let's imagine that other universes are identical or similar to our own, consisting of many galaxies, stars, and planets. There could be so many planets that on some of them, intelligent life might exist. Their inhabitants may have reached a very high level of development and become masters of their universe. Perhaps they managed to travel from their planets to distant stars, around which other planets revolve, just like our planet revolves around the Sun. Gradually, they might have also mastered many planetary systems in their universe and met local aliens. Everything could be completely different, though. If there are universes in the great multiverse that are entirely different from ours, it is difficult, even for science fiction writers, to imagine what is happening in those universes. If there is life in them, what is it like, and what actions might its inhabitants be capable of. Clearly, not everyone believes in the Big Bang and Darwin's theory of evolution. However, for most cosmologists and those close to science, the Big Bang is now a generally accepted model for the early development of the universe. It's important to note that cosmology as a science was only defined in the first half of the 20th century. Before that, due to a lack of evidence, many scientists produced theories at the level of speculation and unproven ideas. Significant discoveries in cosmology, such as Einstein's equations, which led physicists to the idea of singularity, the movement of galaxies discovered by Hubble, and finally the Big Bang itself, were made less than 100 years ago. In the last 50 years, modern studies on relic radiation, the formation of the structure of the universe, and dark matter have been conducted, confirming and expanding upon earlier developments. For this work, physicist James Peebles received the Nobel Prize in 2019. The first evidence of the Big Bang and the expansion of the universe was the discovery of relic radiation, the microwave background left from the substances created in the early stages of the universe. This radiation reveals hot and cold regions in the initial universe. Scientists studied this relic radiation, the processes of particle formation and propagation, and they concluded about the Big Bang and its approximate timeline. The fact that the initial expansion of the universe and the Big Bang are not the final educational processes is crucial. According to scientists, the universe is now gradually expanding further. The density of matter in the universe is slightly higher than previously expected, and gravity might eventually dominate the expansion model, potentially turning all space into a closed loop. However, opponents of this theory argue that the relic radiation is a vast amount of data that cannot be decoded with 100% accuracy. If the proponents of the closed universe theory are correct, this challenges not only current cosmological theories but also the laws of physics and mathematics. It's not certain that the existing expansion theory of the universe fully accounts for special matter that could compensate for the effects of gravity and affirm that space is truly infinite. During the 1960s, American scientists Arno Penzias and Robert Wilson discovered cosmic microwave background radiation, or relic radiation, noise that fills the universe evenly. This showed that space isn't entirely dead and cold but is filled with relic radiation that warms the room temperature to -270 degrees Celsius, -454 degrees Fahrenheit. This residual heat is evidence of the warmer state of the universe after the Big Bang. Among the questions that particularly concerned cosmologists were the formation of structures in the universe. How and why did galaxies form in clusters due to the Big Bang? How did small changes in the formation process lead to such complex structures that we now observe? Another closely related question concerns the properties of the relic radiation found in 1965 by radio astronomers Arno Penzias and Robert Wilson. When it was discovered, scientists calculated what properties this radiation should have and what that says about the origin of the universe. By estimating the time it takes for the universe to grow from a point to its current size at a specific rate of expansion, called the Hubble constant, and considering its temperature, we estimate the universe's age to be around 14 billion years, give or take 1 billion. This conclusion is confirmed by astronomical observations of the oldest objects in the universe, mainly small stars with a low rate of burning. However, these stars couldn't have formed sooner than 500 million years after the Big Bang, so determining the universe's exact age from them was challenging. Now, it is estimated that the universe is about 13.8 billion years old. The Big Bang theory is more than just a simple description of the universe's expansion from a tiny point to its current vast size. It involves a series of events that altered the initial state, determining the structure of matter and the organization of the universe. All of this occurred within a fraction of a millisecond after the initial. Enigmatically, it looks like the cooling of steam, furthermore, its change into water and afterward into ice. Each stage prompts a change in the state of matter, gaseous, liquid, or solid. This is called phase transition. Yet, in the beginning stages of the universe, the changes were much stronger. We don't really know anything about the initial phase from which they started. 3 significant achievements led to empirical evidence for the Big Bang. 3 observations that, even if neither Einstein nor Lemaitre had existed, we would have to concede, for better or worse, that the universe was dense and hot at the beginning. These are the observations of the expansion of the universe made by Hubble. These are observations of the cosmic microwave background. This corresponds to the observed distribution of light elements, hydrogen, helium, and lithium in the universe, in the quantities that would have occurred in the first minutes of the history of the universe. Let us know which of these elements and facts about the Big Bang were unfamiliar to you, and which ones you already knew. Share your viewpoint with us, as always, by using the comment function.